Yeah, so today we'll be covering a very short concept. The other time we're looking at how we could use indexer tools to interact with um, interact with a blockchain and query information data from a blockchain through static calls. So today we'll be using a different protocol. We've been working with the HTTP protocol and using it to get data from a blockchain through indexers, all sorts of data, and we looked at a couple of them. Maybe I could, for those that weren't around, just show a few of the platforms that we've been interacting with. Okay. So we're working with indexers, specifically platforms that are designed for analytics and scraping blockchain data. We worked with Dune, we worked with Covalent, and we'll get back to them in a couple of days, looking at some of their other services. So we built applications with these. The sessions are actually uploaded already, so you can always go back and look at them. We worked with the Gold Rush API from Covalent. We worked with the SIEM API from Dune, and we looked at how we could actually fetch data for different accounts, balances of tokens, transaction histories, DeFi positions, and all those kinds of things. But the issue with an API request, with the HTTP protocol being used to interact with a server, is that it only gets a response if the client makes a request. So if you get it, we have an application, probably a React application, excuse me. For it to get any information from a specific server through an API request, excuse me, using the HTTP protocol, it would have to make the request before it can get the response from that specific server. And in certain situations where we might need, so it's typically this kind of communication pattern where the client makes a request and then the server gives a response. So unless the client has made a request, the server does not respond to anything. So everything really depends on the front-end application, and there are limitations to this kind of communication protocol, because sometimes if the client wants to respond to real-time operations that are happening on a blockchain, it would have to consistently poll the server. Polling simply means consistently querying the server for any changes in the information it probably already has and maybe wants updates. And it consumes a lot of resources, but it's also unreliable because it would affect the way our application runs, including probably affecting how fast it can render on screen, because it has to continuously make requests to the server. So it's always in a process of making requests. For it to sufficiently be able to receive real-time data, it has to make requests almost every single second. You know, for instance, if I wanted to find out if the price of ETH has either dropped or increased, and maybe I'm doing some calculations on the front end basing on that fact, the only way I would find out if the price of ETH has dropped or increased, I would have to query an API, maybe query the price of ETH from the CoinGecko API. CoinGecko is one of the API pricing servers that we could use. So you can get your prices and a lot more other information about the market dynamics of tokens, including things like market capitalization and current prices in the market. But if I do not have a mechanism for me getting updated if the price of ETH has dropped right at the time when it has happened, or if the price of ETH has increased right at the time when it happens, that the front end receives a response or receives a message from the server, then I cannot sufficiently or effectively do real-time calculations or operations basing on that data. Otherwise, I would have to always occasionally query the server for that specific data point, and basing on whether there are changes from what I already knew as a client, or the data is still the same, I would have to respond basing on the results. But the issue is, can we have a system or a communication channel where instead of us continuously querying the server, we can have a communication system that is persistent? You know that if there's information coming from the server, even if the client has not made a request, there should be information that is flowing across. Or even if the client can send a message to the server, but the server doesn't always have to wait on a request from the client to send a message when it has to. For as long as the criteria stands for it to send a message back to the client, it should just send the message to the client through that communication channel that persists between the two resources. So the specific communication protocol that we're going to be looking at today, and we're going to be just really introducing it, is WebSockets. So for those that might not know what a WebSocket is, so a WebSocket is just a full duplex communication line between a client and a server. I have a depiction of it that we could look at here. So think of it this way. When you look at a server making an HTTP request, the client has to send a message or make a request to the server before they get a response. So they would only get a response if they made a request. But with a WebSocket, the only time we need the HTTP protocol is to initiate the handshake, and then that communication channel is upgraded to a WebSocket channel, communication channel. So essentially, what typically happens when a client sends a request to the server, it creates a communication channel, and after the client receives that request from that socket or that specific communication point on the server itself, it will send a response back to that point, and then the communication channel will close. That's typically what happens with an HTTP request response cycle. But with a WebSocket, the communication channel persists. It's actually called a socket. So think about let me use an analogy. If you got an Ethernet cable and connected it to a machine, it would send signals between that machine and maybe the router. So, for instance, if you wanted to download a movie or maybe a file, and you connected the Ethernet port to the computer, and right after the file is downloaded, you removed it, that would be an example, an analogy of how an HTTP protocol works. Like every time the communication is complete, the channel is closed automatically. But with a WebSocket, think of it as a way you would leave your cable into the computer, so that if there is any kind of updates coming, maybe from the internet, you always get them on your PC at whatever time they come. For instance, if you connected your WhatsApp to the PC, you'd get notifications right in time. So in the same context, when a handshake has been initiated, so a handshake is just a process of creating a persistent communication channel between a client and a server. So the preliminary process of enabling the persistence of that channel and upgrading it from a standard HTTP channel to a WebSocket channel is what is called a handshake. So that one would require us to use the HTTP protocol. But then later on, when it's upgraded to a WebSocket, there's a channel between the client and the server that allows them to both communicate simultaneously. That's why it's called full duplex. That information can flow in both directions right at the same time. Different from a half duplex, I'm sure you've seen how walkie-talkies work. You cannot communicate, you cannot talk as the other person on the other end also talks. You'd have to wait for them to finish communicating, and then you respond after they have stopped talking. So that's an example of a half duplex two-way channel where communication information can only flow in one direction at a time. So Actually, another example would be the HTTP request response cycle. Typically, that's what it is, a half duplex. You first make a request, then a response comes back from that request. So for us to work with WebSockets, I just want us to maybe interact with an event on a certain smart contract, so that we track the specific instances at which that event has been emitted, and then query them and display them on the front end. Maybe do some things with them. Okay, so for us to be able to do that, I'm going to create a simple application. Let me see. So I prefer to use PowerShell. It is very convenient. So inside here I have a folder, this, and I'm going to create a folder called maybe event tracking. Maybe this would be inaccurate. Let me create a folder called smart contracts event tracking. Okay, so inside here I'm going to create two other folders, one for the client or the front end and one for the server. So we'll create a simple backend component that is going to be interacting with the blockchain to get information from the blockchain, and then the client that would get information from the back end onto the front end. Something very small, but hopefully it teaches us the fundamentals of how WebSockets work and the extent that you can take them if you decided to use them. So let me create another folder here and call it the client. Maybe another, and call it the server. So I'm going to start with the server, and then I'm going to test it with an API testing tool before we actually work with the front end. Okay, so here I'm going to initiate a backend program, a node backend program using Express.js. This is how you'd create an application, a backend program, npm init-y. Okay, I think I have the application already. So let me get back to the event tracking folder, because I want to open it with both of them visible. And then for some of the things that we'll need later on, we can always come back to it. Okay. So you can see this is the folder, and it has two subfolders inside it. One is called client, the other is called server. So the one we're going to be working with first is the one called server. And we're going to create a file in here called index.js. And this is why. So when you look at the package.json, this is like the blueprint of the application, the backend program. So it shows us the name of the application, the version. I could put a description here. But then the entry point into the program is going to be called index.js. I can change it to anything, but I'm going to stick to this because it's just the convention. I can change it to anything and create the file of that type. So inside the server folder, I'm going to create a file called index.js. Then in here, I'll write my code base. So the very first thing that I would need to do is import some of the things that I will need. First of all, let me create a server. So let me see. Let me try to maybe note down some of the things that we'll need. So first of all, we'll need we need a WebSocket server. So that's the one that we're going to use to create a server that allows us to interact in real time with the front end. We need a WebSocket provider. This is the one that would interact with the blockchain itself and then return results for us. And we would need, what else would we need? We would need an HTTP server. Now this is the one that would interact with the WebSocket server first, rather with the WebSocket provider, for us to be able to, okay, the client would interact with the HTTP server first and the WebSocket server then, but the WebSocket provider will interact with the blockchain. This would interact with the blockchain. This would interact with the front end, and as well this would interact with the front end. Okay, we're going to start with maybe a simple server. So I'm going to first import the HTTP package. Let me start from the second line and remove this HTTP. Then I'll use the common JS syntax. I'm importing HTTP. So this is already embedded within Node itself, so you don't have to import it as a package. But for the other things that we might need later on that are not native to Node, we can always import them. Just a moment. Okay, now the other thing that I'm going to need, so I might not exactly need Express for this. So the other thing that I'm going to need is WS server or WebSocket server. So I'm going to import WS first of all. From where, I need to import it, by the way, as a package because it's not native to HTTP. So I would have to go back to the server folder and then import WS, which is the package that should allow us to create a WebSocket server and be able to interact with our front end. So npm iws. Okay, so it's imported already. Okay, so maybe the other thing that I would need, let me see. So first of all, let me start with the HTTP server. So I've already imported HTTP and I'm going to create a server here. Let's say HTTP create server. Now I could give it a listening port and say server.listen. Then inside here I specify the port it's going to be listening at, maybe 8000, port 8000, and then a specific method of what it would do when someone connects to this port, to the server through this port. Or rather when it's live, sorry. So I'm going to say it's a console log. Maybe put a message that someone can read. Say server is online. And we're going to test this right now, see if it actually works. So inside the server folder, I would call node and then the name of the file index.js. So it reads server is online. So right now, if someone wants to interact with this application, they would be able to interact with the application. But then I need to create a I need to create a WebSocket server that will allow me then to interact with the front end in real time. So that's what I'm going to do now. So I will also import it here. I would import WebSocket server from WS, but because it's not a default export, WS, I think this is WebSocket server. Now that I've imported WebSocket server, I can now create a WebSocket server directly from here. Okay, so we have an HTTP server already created, but you remember when we looked at how WebSockets work, is that for it to be able to interact with the front end, it needs to work through an upgraded HTTP request, rather HTTP server. So that channel persists. It's as if the WebSocket is a subtype of an HTTP protocol, only upgraded that in the case that it allows persistent communication between the client and the server. So we need to have an HTTP server connected to the WebSocket server so that the requests would definitely go through the same protocol to reach the front end. And that's what we're going to do now. So I'm going to create a WebSocket server. I would call it maybe WebSocket server. And I would create it from this class, WebSocket server. And then inside here, I would pass in the server property that I'm going to be using. So what is the server in this case? The server is this HTTP server. Let me put it below so that it aligns well. So because the name is the same, even if I left it like this, it would be perfect. It's just a shorthand for if the key and value are exactly the same name, you just type the one value to represent both. But if I had this as something different, maybe HTTP server, I would have to then type the key here as server so that it can reference that value from the state around it. So I'll first turn off the server and then start it again for you to pick the updates. And server is not defined. Oh yes. So I modified this. Okay, so the server is online now. Now we have a WebSocket server, but for it to be able to interact with any client, it needs to have a listening event. For it to be able to get connections from clients, it needs to have a listening event that allows it to connect clients that are going to have their connections persisted between the server and the front end itself. So I would call a specific method on the server, on the WebSocket server. So the on keyword is used when you're going to type event listeners. Now specifically, I'm looking for connections. So when there's a connection, when someone attempts to make a connection to this server, this is what should happen. So I define an callback function of what I should do when someone initiates a connection. So two things happen. When someone initiates a connection, when it's created, two things are are passed into this array, rather as parameters to this callback function. First of all, the connection object. That's the object that contains all the methods that are required for you to send messages back to the client. So there are so many methods and properties that you can work with from this connection object. And then the request body. So when someone is making a request to a WebSocket server, it looks something like, let me see. Let me first open Postman. So Postman is one of the tools that I use to test all my backend services, whether it's WebSockets or working with standard backends. I would use Postman. So we're actually going to use Postman. I already have a workspace. If I attempted to make a new request, a request would look something like this. Actually, there are examples here that we might look at. So that's how a simple WebSocket request or the WebSocket path would look like. If it has WSS, it's a secure one, just like you have HTTPS. And if it's just WS, then it's just an unsecure WebSocket path. So usually, if it's going to be on a local machine, of course, you'd have to specify the port. Just like, of course, this would resolve into the original socket that it was derived from, that this domain was derived from, or is indexed to. So my local machine will be represented by actually this link, this specific socket. I can change this to localhost or the default 127.0.0.1, and I specified this port. I could even change it to 8080, but my specific server is listening at that port. Okay, and when I go back to my application, so I'm saying what is going to happen when someone attempts to make a connection. Maybe I should print a message to the console here that says there's a new connection. But also, since I already have the connection object, I can send a message back to the client that is attempting to connect. I can send a connection. So on the connection object, I can click on the send method and then send a message back, although it has to be in a format of a JSON format, or just a simple text. So I would say, welcome here. So I'm going to try and test this with Postman and see if it actually works. So there are no logs yet. When I attempt to connect to this port, when I attempt to connect to this server, I want to see if I have a response. There's a console, there's a terminal. Yeah, I want to see the console. Maybe the messages. Okay, so it says it's connected. There's somewhere I'm supposed to be able to see the responses. Oh, the server online. No, I need to turn it off and turn it on again. So there's this issue with a basic JS backend. You would always have to restart the server, or you could use a specific package called NodeMon. It's a monitor for any changes that happen in your server, and it would restart the server automatically for you. But I'm not going to go into that because it might take us a while. So now that the server is online again, with all the updates that I made, it should be able to, let me disconnect it. Oh, it's disconnected already. It should be able to send a message back here as a response after I connect here. So when I attempt to connect, it sends a message back to me saying you're welcome here. And then it also logs a message on the, is someone asking a question? Someone asking a question? Okay, no one. All right, so far we have our backends. Oh, there was a message. Sorry, I didn't. Okay, if I may ask. If I may ask, does this have a very best application? So I don't know what scale of setup you're talking about. Do you mean the entire setup, what I've been writing right now? Okay, so since we're going to be interacting with a WebSocket, we needed to set it up this way. And maybe I should explain this in detail. So when I was talking about the HTTP server and the WebSocket server, those are two protocols that are actually dependent on each other. So a WebSocket server is some kind of a subtype of an HTTP. Rather, the WebSocket protocol is kind of a subtype of HTTP protocol. The unique thing about it is that it persists a communication channel between the requesting resource, the requesting entity, and the server on which it is defined, if a WebSocket server is defined. So that's why I'm using it here, importing WS as a package, but it's not a requirement to set it up always like this. Sometimes you might need to use Express.js. So we haven't done probably backend programming, but there's a specific package called Express. Now this one is responsible for you building most of the things that you might need in a basic backend application. So typically, you'd find most backend applications having this input and then calling so many methods onto this input. But today we don't really need it. And why I bring it up is that it is not a requirement that you're always supposed to set up your application like this. It just depends on what packages you need and what things you might not need. Although every server should have a listening port, which should be defined. What port is it going to listen at? And maybe if there are some preliminary operations you want to do, immediately the server connects. Those are what you would put in the callback function right here. And then in this case, I'm defining another server called a WebSocket server. So this one would have to listen so this one listens on a port. This one listens for events. See that? So this is a second server I'm defining, although it depends on the HTTP server. This one will listen for events. In applications where I don't need a WS server or a WebSocket server, I would not have to define this. You get it? So I think the only thing that might be standard for most backends is this, that there should be a listening port. But everything else is dependent on the kind of application I'm going to build, everything up here. So it's not, the setup is not a must for all of them, except for the listening port. You always have to have that. And of course, it has to be defined on a server that has already been set up. So maybe you might need to set up an HTTP server using this package or using Express.js. Maybe those are the two critical things. So it might be line 2 and everything between line 15 and line 17. Those are like the standard things that you might need in a backend application by default. Everything else is just dependent on my own requirements for this application. So I already have an application that responds to connections. And when someone connects, it sends a message back to them and says, welcome here. I can even try to connect with a different, I want to copy this. I can even try to connect with a different a different, what would I call this? Different tab. So when it connects, this person connects again, it would, send that message. So if I had specific users, maybe I would track the usernames of those people that are connecting, and then, send a more specialized message to each of them. My computer is a little bit slow. I have no idea why. Is this on? Yes, it's on. So you can see the second person connected, and it says there's a new connection. And that was defined when someone, on the WS server, when someone connects, and it sends this message to them through the send method on the connection object. So every time someone connects to the web server, to the WebSocket server, it assigns them a connection object. So this is the object that has every single operation that you can do between this server and the client. And for every single connection, there's a different object. But today, since we're not going to be looking at connection instances, just how to interact with the WebSocket server, then we can probably look at that later. Okay, so now, I think we've done two things from the list that we had. We have an HTTP server that interacts with the front end. This is working. Let me put a star there. Then we have this. But we don't have a WebSocket provider that is going to interact with the blockchain. So for us to interact with the blockchain, we need to subscribe to events. So let me show you something here before we can actually get into it. So for instance, if I had a specific smart contract I wanted to track, whose maybe a certain event I want to track on a specific smart contract, I would need to subscribe to the event on that specific smart contract. So I'm going to open Etherscan. And maybe I wanted to track the USDC smart contract and track the transfer event or maybe the withdraw event on that smart contract. So I'm going to look for a smart contract that I can show you here. And then I'll explain what I'm trying to say with a clear display for us. Okay, so these are crypto tokens, and they are particularly stable coins. That means they are pegged to fiat currencies, and all these, so this is pegged to the US dollar, this is pegged to the euro. What that means is that its price does not move far away from the price of the euro, or the price of the dollar. It would always fluctuate within the range. We could actually even look at the price of USDC. Right now, it's somewhere between 90 cents or slightly over the price of a dollar. As you can see, the USDC price today is $0.9999. It's really just a rounded off value, but it's approximately $1. So the price of USDC will always be in that range, and USDC is issued by a financial institution called SACO, and there are addresses on different chains where those contract addresses are deployed. So I want the one on Ethereum particularly. I can get the one on Ethereum mainnet or Ethereum Sepolia, the testnet. Let me get the one on mainnet, because that's where I think we'll find more activity. So we have the contract address of USDC on Ethereum. And when I paste it here, I should be able to see a number of things regarding this contract address, including the transaction history. As you can see, all these are transactions that are happening right now, and they're transfer events, transfer transactions. Some of them are still pending, as you can see right here. They haven't been mined into blocks yet. There's approve here, there's transfer here, but each of these transactions has information about it. It is not just the operation that happens. There is metadata associated with the transaction, and I want to look at a transaction that has actually finalized. Okay, So we were here just 2 seconds ago and the transactions were pending. After a refresh, they are now all finalized. That's how fast blockchains can be. So maybe let me look at this transaction particularly. The Circle contract, I will look at the contract later, but for now, let me start with the transaction. So I clicked on the transaction hash and it gives me every detail about this. So someone was transferring 106 USDT tokens, 106.20, which is exactly $106.20 in worth from the USDC contract onto this EOA, externally owned account. So when you look at this transaction, it has all this information, and we actually discussed this in a session earlier. Things like gas price and transaction fees, and you can even see more details here about the transaction. Any input data that was required, although it is hashed, it is encoded into bytes 32 equivalents of the data itself. So if there was an address here, that address is encoded into a bytes 32. Even the value as well. As you can see, if I try to change this back to what? If I try to change this back to way, it would give me the actual value of what was transferred here. But I won't get into that. I can decode this and turn it back into a value that we can read and then compare to the dollar based on the price of that token at that time. But then there is something very specific here. So this is the overview of the transaction. Then there is the log. When you look at the log, it represents the events that have been emitted from this transaction operation. So when this transaction was being done, there was an event that was emitted. As you can see, there was one event, and it was the transfer event. The transfer event has all these parameters, and the specific arguments, of course, were passed in when it was being emitted. One of them is the address from which the transaction came, which is this one, as you can see here. The address to which the funds went, which is this one. And then the third, the value. So the value, because it is not indexed, it cannot display like this. It has to be in the data value, in the data parameter. But these are things we look at when we start getting into smart contracts in detail. But specifically, I want to track this transfer event on the smart contract, USDC, the smart contract of the USDC token, so that every time someone transfers funds, I can receive that information on the front end and maybe display it even on the interface, perhaps to track the activity of that chain, just like a blockchain explorer does. So when I look at the smart contract here, this USDC smart contract, I should be able to see the contract itself. The contract code is right here. Whenever you see a green tick, that means the code is verified and you can actually see it, the actual code in terms of the logic that was written. This is something that you wouldn't find in Web 2. So for you as a developer, you can always come and verify if the protocol does exactly what it says it does. For instance, USDC is a token, but it's a token, and tokens on the EVM, in the EVM standard, are actual smart contracts. So they are representation of value, but the methods that determine how they are transferred across and the logic of how supply and demand is controlled, everything is written in code right here. So when you look at it, you can actually be able to see the transfer function and the event, the specific event that I want to track. So it's a number of contracts with inheritance, and I should be able to see, this is the contract address. I should be able to see the transfer method. Maybe I should first look for the events. Okay. When you start looking at smart contracts, we'll get through this. There's a proxy contract here. Let me zoom in perhaps. There is delegate here. We'll fall back. So I'm looking specifically for the transfer function. It should be in one of these contracts. There's a lot of dependencies, a lot of inheritance going on here, but everything is documented here. Okay. Maybe Etherscan doesn't show it all, but I can use a different explorer. So let me look at write contracts, for instance. These are all the methods that are responsible for modifying state on the blockchain. Then read contracts. A read contract just represents values that simply, just a USDC contract. Values that simply, rather functions that simply allow you to fetch data from the specific chain. Let me look at this now. So we'll look at all different things like function inheritance, contract inheritance, and so it was probably upgraded. I need to look through it in detail. Sometimes when contracts are upgraded, they only give you a reference to where the upgrade is, and then the specific original contract doesn't even appear in the upgrade. But I should be able to see transfer here. Somewhere here. I want to show you the actual function and the event that is emitted from that function when it's called. Say if ERC20, yes, it should be here. ERC20. Okay. So here is the transfer function, but just the signature of it, not the implementation. So it takes in an address and the value that should be what? The value that should be spent. I should see the events as well. Events are right here. So this is the event that we want to track, the transfer event, where we have the address from where the value is being transferred, the address to where the value is being transferred, and then also the value itself. So when you look at the event we were looking at earlier on from the transaction we were trying to see, it looked exactly like this. When I look at the logs of this specific transaction, it had this event emitted, and this is exactly the event that we're going to be tracking in our smart contract. Okay, so when I get back to the code, now for me to be able to interact with the blockchain, I need to use a specific set of libraries called Web3 libraries. So there's a set of them, and we worked with some of them even in the previous session. We worked with VM, we worked with Ethers.js. I don't think we did, but it's actually the one that I want to import here because it's the one that will give us the most elegant access to the blockchain. Otherwise, we'd have to wrap a lot of code bases for us to interact with the chain if we were to use any other library. So I'm going to import Ethers.js, and I could share a link to the documentation. Probably, if you're interested in getting to read about it more before we start getting into smart contracts, it will probably give you mileage before we get into that. So I'm going to share the link here. So you can read about Ethers.js. It is just a library that allows you to interact with the Ethereum Ethereum blockchain, but also EVM compatible chains. Anything that operates on the same standard architecturally as Ethereum. So that means things like the design philosophy, and the way it interacts with the rest of the machines or the nodes that that are running on that specific blockchain is just the same way that Ethereum operates. All those chains have the same standard, and Ethers.js can decode data from those chains and also write data to those chains. So that's the library that we're going to be using. And when I want to import it, I will import it as a package, npm install ethers. It's a very small package, shouldn't take a very long time. And yeah, maybe I could even start writing the code as it imports, as it installs. So our server is connected, by the way, so any updates we're going to make now, we will have to restart it. So this is how I would import it. Import ethers. Acquire ethers. Okay, then from the ethers component or the object, I am going to create a WebSocket provider. Let me call it WS provider. From the specific class, actually, new ethers. I'm sure you remember what classes are and how we use them to create objects that we can interact with. It's a WebSocket provider. Yeah. So like that. Now inside here, I would pass in the path to the WebSocket that I want to interact with, the WebSocket server I'm going to be interacting with. But specifically, I'll be interacting with the WebSocket of an RPC. So an RPC is kind of like the domain of a node. A node is a machine or a computer that runs as a validator on the network or a client on that network. And I think we looked at those things in the very first sessions. So we need to find a specific WebSocket RPC. And there's a specific platform where we have WebSockets and RPC via the HTTP protocol for so many chains. It's called Chainlist. So if you want to find an RPC, whether via the WebSocket or the HTTP protocol, you can find it here on the Chainlist website. So you can see we have a number of chains here. And each of them, when I click on this arrow, it can show you the RPCs for all these chains via both protocols, the HTTP and WebSocket, WSS. So I'm specifically interested in the Ethereum mainnet WebSocket. So I'll pick one that reads WSS, then take it out. So they keep changing a lot because nodes keep going on and off. Some are more active than others. So I'll take this perhaps by DRPC. So DRPC is a node as a service platform. Okay. But we'll also look at those things in detail later. So when I pass this here, now I have a WebSocket provider. And if I attach this to a contract address, it would be able to track that specific address. It's almost like I'm requesting. So these nodes act like peer-to-peer servers. So it's as if I am asking a specific server on the blockchain to track a specific smart contract for me. That's what I'm going to be doing. So every information that comes from that smart contract regarding the query that I made is going to be brought to my back end automatically. So now I need to first define a contract instance that specifies which contract I'm going to be tracking. So how we create a contract instance in Ethers.js, we do it like this. So I'm going to define a contract contract instance, and then I create a new contract. Ethers.contract. So in here I pass in 3 parameters: the contract address, the contract ABI, and the provider. So these are 3 things. So the provider can be different depending on what protocol you're going to use. For instance, if you're sending transactions to the blockchain, you would use the HTTP protocol provider, where you would pass in the HTTP RPC here, but of course not as a WebSocket provider, but a browser provider. Of course, if you're working with a web extension, but today we're working with a WebSocket provider. This one just fetches data from the blockchain and returns it to us. So this provider is going to be that provider, WS provider. So a provider is just an interface for interacting with the blockchain. There are different types of providers depending on what operations you're going to be doing, and each of them has limitations. Now, this cannot send transactions to the blockchain. It is just used for fetching information from the blockchain. And but the browser provider, the one that we use to interact with the browser extensions, the one that we would use to interact with extensions like MetaMask here, and then maybe sign transactions, that one's called a browser provider, and we can access it to the browser object model, of course. And we looked at some of these, but we'll also get into it later in detail. That one can send transactions. That means you can reduce funds from your account and send them to another from your application using that kind of provider. But this one just fetches information from the chain. So now the ABI is a contract interface. So we're going to define an ABI here as well. It's a contract interface that guides applications on how to interact with that specific contract. Then an address, of course, is the location of the code base that you want to fetch that specific event from. So when I go back to my browser, I had the address of USDC here. Actually, when I click on it, it would take me directly to the Block Explorer where the contract address is. So you can see this is the token address, and we actually looked at the code and then saw the particular transfer event that we're going to be tracking. Okay, so now this is the contract address that I need to pick. So it has a name because it's verified, but it's really a contract address. It's really a contract with a contract address. Now I have to find the contract address, but let me use it from here. So this is the address of the contract I want to track. And now, when I come to my code base, I will just put the address here as a string. So this variable, the address, would resolve as the address that is passed into the contract instance that I am defining. Now the ABI, like I said, is an interface. This one has a special syntax. So it's an array of definitions. It's an array of definitions. So let me look for. It's an array of signatures for both functions and events. So when I come to the contract here, these are all functions, but if I wanted to call these functions specifically, the ABI of this specific contract would have what are called signatures of both the functions and events. So a signature is just a function definition without the implementation. So for instance, for this function, the function definition would start from here and end there. So this is just enough for a person that is going to call this function to know how to call the function. That means the name of the function and the type of the parameters that they are supposed to pass into the function. So that's what a signature is when it comes to Web3, or when it comes to EVM smart contracts and functions and events. With this, if I wanted to call this function and I had only this, and maybe pasted it there, this is sufficient for me to interact with this with that specific smart contract, because I have everything I need to know about that smart contract. So if I have just the signature, which typically looks like that, that's enough for me to interact with that smart contract. Now, if it's an event, the difference would be that this would be an event. See that? So now, actually, I have an assistant, a coding assistant that keeps doing things for me. So this is actually what I wanted to define. A signature of specifically the transfer function, the transfer event rather. Now, an ABI can contain all the functions and all the events of a smart contract, but you can always reduce it to specifically the functions that you might be wanting to interact with. So this is a complete ABI, although I just shortened it. So this specific address has a number of functions and events, but I'm going to be only tracking this particular event. So it's the only one I have to represent in the ABI and nothing else. So now now I have an instance of a contract. Okay? But what am I going to do? That every time someone connects, perhaps I want to log the events, the event emissions of this transfer event. So that means every time someone transfers funds from one address to maybe some other address, it would emit for me specifically the information from that emission. So now if you want to track an event from a smart contract, you need to have an event listener as well. So what event am I going to be tracking? I'm going to be tracking the transfer event. So yeah, when someone transfers their funds, what should I be doing? That's what I'm going to define in this callback function. So this has parameters depending on the parameters of the event itself. So this event has 1, 2, 3 parameters. Okay, so the first is an address where the funds are coming from. The second is an address where the funds are going to. The third is an address, a U-256 that represents the value in way of the funds that have been transferred. So I would call this value. Now, after all the parameters have been accessed, there is also another special event, another special parameter that represents the entire event. So if you wanted to do some operations on the event objects, you can access them there. But I don't think I need it. Anyway, let me leave it there. Probably I could do something with it. So now, every time there's a transfer operation, what am I going to be doing? Maybe I can print the results here. Let me see how I'll do it. Okay. So probably let me start with this. So it will print for me the address from which the transaction started, from where the transaction was derived, tx.origin, and maybe where it went. So I'm getting all these specific variables from the parameters that were passed. As you can see, they light up when I access them inside. And maybe the value here. So the value would be in way, but I can actually convert it using a specific function from ethers.js from way to eth. Then from there, I can even get the value in fiat, in terms of dollars, in terms of euros, even Uganda shillings if I want. Okay, so I have this here now. And let's see if it actually works. So that means every time someone makes a connection to the server, I am going to print this on the console, but I can also send this to the client themselves, which is what we want to try to do. But let's start here and see if it works. If it prints all the events. So now the server is online, but we don't have anyone connecting to the web server yet, to the WebSocket server. So let's attempt to make a connection to the WebSocket server and see what happens. So when I connect, it's going to tell me welcome here, then continue to print the events here on the console or the terminal of the server. Click connect. When I connect, it says welcome here. Let's see what happens here. Are there any events being transferred, being displayed? Not at all. Okay. Oh my God. Okay. So there they are. Now those are specifically transfer events. Every time there's a transfer, and there are many because, as you can see, it's almost non-stop. Because we picked one of the most actively traded tokens, USDC. It is used in DeFi protocols. It's used in lending protocols. So all those operations happening in those different protocols co-functioned on that specific contract, the USDC contract, and these are all the events that are being emitted, where funds are coming from, where they're going to, and the value. Okay, so now we have it in the console. You can remove this data to a client that is connecting to the server. Let's try it and see. So it's non-stop because we subscribed to the event. When we did this, when we set up an event listener for the transfer function, we subscribe to the event. That means every time that event is emitted, we're going to get a message. We're going to log that specific emission onto the server console. You can see the list just doesn't stop because there are transfers happening everywhere. When you looked at this, I think when you looked at all the operations that were happening here, the transfer event is almost the only function that is being called. Rather, the transfer function. So the transfer event is actually inside the transfer function. It's almost the only event that we see on the Block Explorer because people are transferring funds across. So transferring funds from their addresses to protocols like BitGet. You can see here, BitGet is an off-ramp solution. You can transfer your funds from crypto to fiat using BitGet. So these are smart contracts for either users or actual protocols like BitGet. Some of them would have names, actual names, because they are verified, and the contract names become references to the actual contract addresses, just like you can have a domain for a particular server. And there's a number of them. There's BitGet Hot Wallet here. So some of them are just externally owned accounts, others are actual smart contracts. Okay, so as you can see, the transfer function is the most active. Maybe let's try watching a different event, probably the approve. It might be slower, so we might get results a little bit slower because you can see even here we have only 2 approve functions. So what the difference between transfer and approve? They actually do different things. So the approve function is used for you as a user or the token owner assigning someone else rights to spend those tokens on your behalf, and you can stipulate the amount that you want them to have access to. So if you have maybe $15, you can assign them $2. So after they've spent $2, they don't have access any further. It also has an event. We can look at the event. it has the address of the owner, address of the spender, and the amount they're being assigned to spend. So we can also track this. Specific event, but we'd have to put it into the ABI so that when our tracker or our specific event listener is checking for that information from the chain, it knows how to craft it back to us after it has received it from the blockchain. So you can see these events have not stopped. When I scroll to the very bottom, it continuously goes because it's a it's an actively used function on that contract. People are transferring funds all the time for different things. Either they're opening trading positions or lending positions, doing a number of things, or just transferring money across. So now I'm going to be tracking a different event. So I'll just put a comma here. So what event am I going to be tracking? The approve event. I'm going to be tracking the approve event. So this is not something you can do with an API request through the HTTP protocol. Because data comes once as a response, even if it comes as a data stream, you can only pick what you can pick and convert at a specific time. You won't be able to receive all this data continuously. But because right now we've established a connection between our back end and this specific RPC via WebSocket, we receive all the information as soon as it arrives into the log of the blockchain. We receive it directly through that node, this specific node RPC. Okay. So this is an address. I'm going to remove this. And we're going to now track the approve event. It is a little bit slower. This is indexed. Even spender is indexed. What this means is that it makes it easy for us to. So the event can have a number of parameters, but only only 3 parameters can be indexed. What that means is that it makes them easier for you to view them, and you don't have to take them through a process of decoding. The rest of them are bundled into one object called data, which is also a byte 32, but can be decoded into its individual components, basing on a layout that was defined for that event. So the same thing happens even for storage, but so I'll get to that when we get into smart contracts. Okay, now when I change this event listener, so I'm going to have to stop the server now. So when I change this event listener from transfer to approve, I expect the results to come back a little bit slower because this is not a function that is often called. So the events that are emitted from that function on its invocation are going to be a little bit slower. But you see now we're tracking a third-party smart contract, but we can do the same for our very own smart contracts. If we create our smart contracts and define events on those smart contracts, we can track those events ourselves. Maybe on a front end, for instance, if someone was, let's say we built a smart contract for DAO voting, but it has an event when someone makes a vote. So if someone voted, for instance, you would update the status on the front end that's, okay, we now have 6 votes, we now have 10 votes, we now have 15 votes. So that everything happens in real time. And if this is very critical if you're building an on-chain game where information has to be moved across in real time. For instance, if we built a card game on-chain and all the different players would need to know the state of maybe how many cards another person has before they could determine the decision they take on which card to play. This is information that needs to move across in real time, and we can have all these things tracked. Not just events, but also the other forms of state on the blockchain can also be tracked, including state variables and the changes on those state variables. And all that information can be tracked using a WebSocket protocol. So it can make a lot of things much faster. And we'll get into things like sessions and how we could use them to create applications that are real-time tracking of data. So on the approve function, on the approval, sorry, it's called approval function, event rather, we have three parameters. We have the owner, which is an address. We have the spender, which is also an address. Then the value, which is a U256, or the way value. So I'll just change this to owner, but I could even still leave them the same. I just want to give them appropriate names based on the specific event that we're tracking. So the owner, then the spender, and maybe spender here. So since this function is a little bit slower in terms of its traffic in the number of people that call it, we might even be able to track the specific smart transactions when we look at the blockchain explorer itself. So I'm going to run this again and see what happens. So the server is online. Now every time there's an approval event emitted, it will display here from specifically this smart contract. We saw how transfer worked, but we can go back to the block explorer and see, maybe even watch for ourselves. If there's an approval event, an approval function invocation, we'll be able to see it here. I think Block Scout is much better. Maybe I should open Block Scout. So I would have to keep refreshing this and see which methods have been called on the most recent blocks. But you can see it's mostly the transfer function. So the transfer function has the transfer event. I don't think I might even see approve being called here anytime soon. It's one of those functions that people don't call very often. So now I'm tracking live data, but originally when we were looking at APIs, we were tracking historical data. So I would be able to track the approve event emissions that have happened seconds ago with an API request using the HTTP protocol, but I won't be able to get those that are live, probably happening right now. So this, I might not be able to see it, maybe because I created my WebSocket connection after that event had been emitted. Otherwise, if I use the HTTP protocol, I'll be able to see it in the history. Let's see, has there been anything emitted? No. And as well says the Block Explorer, nothing has been emitted from the approve function. The approve function hasn't been called at all in the past 8 seconds. So we could be here and wait. It could be called in the next 1 minute or maybe the next 1 hour. But you've noticed that the most called function is the transfer function. So we're going to stick to it and use that data further. Maybe now starting to display it on the interface. We could create our client. We could create our client and display that on the interface. So I'm going to go back to the transfer function so that we're able to. Yeah, I think that's enough change. I can leave my ABI to still contain the approval function, rather event. The server is online and I'm waiting for the stream of data transfer. Once again. So as soon as I receive it, the server is online. Okay. It will definitely display. So now I'm connected to the blockchain and I'm receiving information from the blockchain. But the one thing that I want to do is be able now to transfer this data from the server, because it's only displaying in the console of the server, to transfer it from here and maybe display it on the client as well. So I'll be sending a message to the client. The client doesn't have to send a request for that data. I'm just going to be sending the data. As soon as I receive it, I send it to the client. Okay. It should be showing by now because think the function has already been called a number of times. I don't have a connection. All right, thank you very much for that. So I put all the code inside the connection event listener, so I don't have a connected client yet. In other words, I don't have anyone to send data to yet. Okay, so now I have a connected client. The message has passed. Now I should be seeing the data stream already. And there it goes. That's the data stream now. So I want to transfer this data now to the client. Every connected client should see this. I could do a broadcast, but I would have to track all the clients maybe in an object where I have their keys and tracking them in a certain way. But since I'm going to have only one client, we'll look at client instances later on. Now, what I'm going to say is every time I have a transfer event emitted, print to the console, but also send the message back to the client. Now, the connection object, like we saw, by the way, you can only access information from the object that is assigned to a specific client connection inside the connection event listener, because that's where it's been defined, and that's where the connection object has been defined, unless you're going to pass it into a state variable that you've defined outside the event listener. Otherwise, if you're always going to just call the connection object, you have to call it inside the event listener here in the callback function. But it doesn't restrict you. You can always put it in a state variable and then define how you call it elsewhere outside the event listener, but it has to be in here by default. So I'm going to send a message to them, but it has to be a JSON object. That is a serialized version of a JavaScript object literal. So JSON.stringify is the method that serializes the specific objects into the JSON formats. And since the names and the values are the same, the keys and values are going to be the same, I could just use the shorthand. Now this message should be returned on the console here, on the console of the client now. So beyond this message, I should now see this data continuously being added on top of this. And exactly what I'm doing here is what I can do in a React application. So I'm going to have to close the server again and then restart it. Okay, so I'm going to create a connection. Let me first remove all this. When I connect the client, it says you are welcome. And then it should now start to give the client information of all the events that have been emitted from the transfer function. Okay. Is there an issue? Should be able to do that. Okay. Should be able to send the messages. Let me look at the code base. Okay, the event listener is on. That's the connection. JSON.stringify. Okay. So it should be able to send that information, because that's the method that sends that sends messages to the clients. Received messages. Is it running? Okay, it's not showing, but let me figure out why. But at least by now we can already appreciate the value of using a WebSocket over a standard HTTP request. Is that you have a stream of data that can continuously be delivered to you as the client. And we're going to be looking at third-party WebSockets for indexers that we could actually fetch data from. Particularly, I saw one that I think would be very good for us from CoinGecko for fetching prices of the market prices, points of the market prices. So if you look at market charts, they have about 5 price points being delivered at every instance, each representing a specific price point. It's called OHLC data, but we'll look at that when we're looking at candlesticks. So we could actually write an entire platform, trading platform, ourselves. We are connected and we should be receiving that data. Contract instance. Okay, so let me try to do this in a React application and see. So for now, so far we've set up our server. So far we've set up our server and it's fully running. But now I want to set up the client. Okay, I want to leave the server running in this folder. In this, let me just create a new terminal, I think. So the node server will be running here. Then this other terminal will probably run the client server. Okay. Inside the client, I'm going to create a basic React application. npm create using Vite. The word is actually Vite. I don't know why I keep calling it Vite. But anyway, so a simple React application that we can use to interact with the backend server. Let me call it event tracker. Building it with React, with Speedy Web Compiler. And I want to install my packages as well, all my dependencies along. So I have 2 servers that will run in this console. The backend server and then the client server. But the events are continuously flowing up to this point. I could actually track some of them. I might even display the transaction hash if I want. Why they are not displaying on the client, I have no idea. So yeah, we have all this data coming from the blockchain. Let me look at my internet. Okay, I think we're stable. And our application is running. So I'm going to let both applications run here, both the back end and the front end server. So this is the back end server. So I'll switch to the client and look at the application that's, yeah, so this is a default React application using the Vite template. Let me open it. Let me open it here. It's running at that port. So now I want to connect it to the back end that I just defined. And let me comment all this out. I don't need it. I don't need the state variable. Okay, so I'm just going to type a heading here. Say maybe the transfer event, because that's what I'm going to be tracking. So it should just show that the transfer event. And I'll open the console to probably display my data first and see how it flows before I can display it on the interface. Okay, so right here now, we're lucky enough that React has an inbuilt WebSocket API that we can use. So I'm just going to define a WebSocket instance here and say WebSocket. So just like you see it here, I passed the WebSocket class, then defined the specific WebSocket I'm going to be interacting with. So in this case now, I'm going to be interacting with my local server because it's the one that has access to the browser server, to the blockchain server, to the blockchain WebSocket, and I can get information from there. Okay, so what is the path to our local server? The path is right here. And that is it. So if I had query parameters, I would pass them in here using the question mark tag, or as or inside an object for options. If I had any query parameters, now just type query params here, and then the query parameters key and value, whatever the key is and whatever the value is. So the key would be there, and then the value. Then you can destructure them on the back end and use them for whatever you want. But yeah, we don't have any query parameters, so we'll stick to the link itself. Okay, so we have a WebSocket that we've already connected to. Now we can sign up. We can create event listeners as well for this specific socket. And specifically, I want certain things to happen every time a connection is created between my client and the WebSocket server on the back end. So what are those things going to be? Specifically, I want to maybe notify the client in the console that, hey, we have a connection to the server that you intended. So the WebSocket connection is created here when the class is being defined. So let me just use this. What does it been defined for me? Connected to WebSocket. Okay, so WebSocket on is not a function. Let me refresh this. What is wrong with this? This is a WebSocket instance. So it should be able to work. Okay. That's it. I'm trying to figure out why. WebSocket on is not a function. Really? Okay, let me test it somewhere and see before I can. Or not, React has a lot of issues these days. I have no idea why. On connect, no, it's an event listener, so it should be. Just a moment. Let me test it somewhere. So I've experienced similar issues with some packages. I think it might be issues with versioning or let me see. Let me try this. So this is the object. If I added an event listener perhaps and see, it's on open. Okay. I think add event listener out, but let me try on open and see as well. It's good to have alternatives. On open like this using camel case. Does it? Probably you could type it in the chat so that we could see it. But I think add event listener works. Otherwise, I would love to see how on open works. Okay. Let me type it right away and look at how it behaves. Okay. Socket is not defined. Okay, well, it's true, it's not defined. Oh, this actually works as well. Well, thanks very much. I've just learned something as well on open. I would keep track of that. So I think then inside here I could define any further operations I wanted to make. Probably if I wanted to send a message to the server, I could do it here as well. But yeah, so let me try to create another event that is actually going to probably receive a message from the server. So WebSocket.add event listener. If you receive a message, I think that will be probably on message from that syntax. I'm not sure. On message. I'm going to try it out as well. So if this would be probably the event that has been returned, then the event, and could get the data, but the data would of course be a JSON object, I believe. So I would have to pass it. I have to pass it into an object literal. The data returned perhaps. So yeah, let me see if this message works, because I think the servers are both running. They should both be running. That is running, then new connections. Hey, I'm having only new connections. Let me did I make any changes to? Let me stop it, perhaps, and try to restart it. And maybe it's running new connections because, let me re-render my application first and see if it will receive the transfer events. Welcome is not valid JSON. Okay, so I'm supposed to type this text in form of JSON. In JSON, we don't have uppercase characters. We don't have objects. We don't have. It's a very good standard for serializing data, but it has quite a number of rules. Okay, the server is online now. Let me render the application. So I should be able to see the events displayed on the interface, particularly in the console of the client, because I'm sending a message back to the client that connects to this web server, WebSocket server. So we just have to watch the console and see if it receives any data. Unexpected token is not valid JSON. Where am I? Connected to web server. Am I sending a message? Is this coming from a message I am sending? No, I think it's coming from the back end. Okay, the events are there, but they're still not displaying. This is on app.jsx line 15. I think this is where I'm sending a request to connect. So the issue is probably coming from the response. It is probably coming from the response. Let me just ignore this. Do I need it? Okay, connection.send. Let me test it here now. Still not showing. Maybe I'm not seeing something now, but hopefully I will in a moment. Oh. So this is why I actually use NodeMon, because I always forget to restart the server. And especially if I'm exhausted, I end up thinking I have a serious exception, and it's just an issue with. Okay. No, nothing still. Let me try it here now. Connected to the server. Yes, Mike, you noticed something? And yet I actually have connections. Okay. So I have new connections. Maybe let me change the port. Sometimes it's funny how sometimes it just works when you change the port. Okay, so my server is now running on a different port. So I would have to change this as well. And even in my client, on my client side, I would still have to change it. App.jsx, I would have to change this port as well. Okay, I have a new connection. I think this just reloaded because it's a it's a hot module, so it just reloaded probably. So if it reloaded, does it show? No, it doesn't show. These are the only two files I actually need to look at because that's where the code base is. So inside the connection, request, connection.send. And this should be sufficient. Because this is the message that would, maybe let me try to send something else, and maybe there's an issue with the object I am sending. Oh, does it? No connection. Let's send, let me send a basic text string, maybe transfer. Okay, the server is online. Now I need a connection. So I'm going to connect. Now transfer is working. So even this side I should be able to receive it. As soon as I reload, I believe. Okay, I think now this issue is just on the front end trying to pass the data that I've sent it. But transfer is actually loading on the screen. So I think maybe there's an issue with my object. I'm going to look at it, but as you can see here, transfer is actually being logged. You can see the timestamps here, but it just represents every time an event is emitted. That's when the transfer is logged. What did I want to change? I wanted to change this from uppercase to lowercase. Let's see what it looks like as that. Server is online. So when I connect it, displays transfer here. Let me reload this. Unexpected token transfer is okay. I just think I need to pass a JSON object now. Let me try this. If I pass a basic literal, I think it's supposed to actually be a JSON object. It's been a while, but because if I pass an object literal, I do not think it is going to accept it. But how would I know? So I connect, and it does not work. So there must be an error on the server even. Probably. It's working. It is, hasn't been stopped. I didn't stop it. So I continuously get the error this side as well. I do what? Stringify? Line 31. I stringify it. Okay. Okay, I create an object literal. Let me just call it message perhaps. from and then here I serialize it, right? Okay. So the server is online. So it's clearly disconnected. What's strange is that the string actually displays, and now here, this one is still behind. Receiving end does not exist. Okay. Now it's totally behind. Okay. So I want to get this data and then be able to display it, but it's playing tricks. Cannot establish connection. Let me look at the port. Okay, I have an event listener and I'm passing the data here. Maybe I should first print the JSON object itself, see what it looks like. Because in that case, I should be able to see the JSON object itself. Yes. The port was okay. And the value, I can really see all the information. Let me connect this one. Now I have to debug this and see where the issue is. But if someone is noticing something I'm not seeing, you can put it up. I might just also be tired. So let me persist on this transfer string and see if it displays on the front end. Here demonstrated that it actually displays. How about the front end? I'm not passing the data. I'm just displaying it as it should be. The data return transfer, as you can see, transfer actually returns, and every time the transfer function is the transfer event is emitted, it also emits the transfer. Here you can see it increasing. These are all instances. Yeah, that's what I assumed. Unless new connection. So every time there is data being passed on the console, as well there is this transfer string being displayed on the interface and as well on my other clients. So okay. Maybe I should just define them differently now because I'm defining the object myself. From to should be 2. Value should be value. Keys in quotes. So let me just define the keys in quotes. Because if I stringify it here, it would resolve the values. So I must have the values of these if I'm going to put this in quotes. Okay, so I do this. Okay. So let me try this now. Okay. Now I connect. Nothing shows up. Let me refresh this. Oh, that is strange. From to value. Is there anything I'm missing out? Because if the transfer event, the transfer string is being delivered, then the issue is with this JSON file. Which I cannot figure out. Let me try sending a raw object. But ideally, this method is supposed to receive data buffer like. Okay. Okay. Because I would have to, if I try to encode it into a bytes array, let me try encoding it into a bytes array perhaps. Although it should ideally send strings. So it might be because also maybe because WebSockets receive data from the front end in terms of bytes. So probably I could turn this into a buffer and see what happens. Connect. No response. But is there a response? There is a response. Okay. It's a little baffling. I don't know what the issue is, but we were supposed to display this on the interface, then be able to interact with it. Maybe display it in an array that is continuously increasing in length, but I can't figure out what the issue is. Okay, have the message. Okay. No response. maybe I will just have to troubleshoot this and see what the problem is. Otherwise, it's always been working that way. Let me see, how else could I send a message? Connection. The request object doesn't have anything I could use. But yeah, so that's an issue. I'm trying to figure out why. Okay, so maybe I'll look at this and see how we can resolve it. But that's how typically you would fetch data from a WebSocket if you were interacting with the blockchain directly. So, okay. I don't know, can we continue on to anything, or we can close here and start tomorrow from here? Because I was hoping that tomorrow we would do connection to WS5. The server is off. I was hoping tomorrow we could do subqueries, like how to fetch data using GraphQL. But now, if this hasn't completed, we would have to complete it first and see how we can actually do this with third-party WebSockets before we can proceed on to that. What is the suggestion? Should we stop here and resume tomorrow, or can we look at something else? Yeah, actually, I was, if I wanted to do, even the third-party APIs would depend on this. It should be able to interact between the backend and the front end. Can troubleshoot that then. Okay, I would agree with that, unless someone has a different opinion. But if we went on without this working, subqueries would just make no sense because it's an entirely new concept. But yeah, essentially that's what we would do. If you look at this, if someone has been building in Web 2, it is closely similar to how you'd work with WebSockets and maybe webhooks later. If we have some time, we can look at them tomorrow. It's very closely similar. The only difference was we had a special library here for interacting with the blockchain and maybe the ABI and the address. I think these are the only Web3 native features that we had in the back end, but everything else is as you would have it in Web 2. So we're going to increasingly have more and more features into in Web 3 as we continue to build throughout the sessions until we get fully in with smart contracts and smart contracts frameworks. Otherwise, I hope today was helpful up to this point where we faced the issue, but I think it was a helpful session. So I'll see you all tomorrow.